Fine. So we'll just go through this example again just to fresh up your memories of what we were discussing. This is the last example which we did yesterday. Manganese oxide and hydrochloric acid reacting to give you magnesium chloride, chlorine, and water. So what happened here? Hydrochloric acid got oxidized and it became chlorine. Why did it happen? Because hydrogen was removed, and removal of hydrogen indicates that oxidation has happened. Removal of hydrogen. Same way here, removal of oxygen happened here from manganese oxide to manganese chloride. Oxygen was removed from here. So removal of oxygen also represents reduction. And remember the 4 questions we have been talking about. What is the substance that got oxidized? It was HCl. And if HCl got oxidized, why did it get oxidized? Because of magnesium oxide. This is the guy who facilitated the oxidation. So Mn2 becomes the oxidizing agent. So I want you to remember this logic. Whichever substance gets oxidized, the other one will be the oxidizing agent. Okay. Same way, what is the substance that got reduced? This one got reduced. Why did it get reduced? Because of the hydrochloric acid. So hydrochloric acid becomes the reducing agent. So this is how you will identify the 4 substances over here. Very clearly remember what are the rules for oxidation and reduction. In the classical definition, if there is hydrogen and oxygen is there in the reaction, you will remember this definition. What was that? Addition of oxygen or removal of hydrogen represents oxidation. Same way, removal of oxygen or addition of hydrogen represents reduction. So this will help you to understand where the oxidation is happening, where reduction is happening. Once you know that, then it's very easy to recognize the other guy. What is the reducing agent? What is the oxidizing agent? Okay. See, I'm going to write down the definitions of oxidizing and reducing agent, but I don't want you to use this definition, at least not for now, unless you are very, very sure. Okay. Use the logic which I explained so far, okay, to identify which one is oxidizing agent, which one is reducing agent. Okay, so first of all, this is today's class. What is this? What's the date today? So oxidizing agent is the substance which gives oxygen for oxidation. Or if oxygen is not involved, it has to be related to hydrogen. So the substance which removes the hydrogen.
So can't we write loses?
Which loses?
Lose, sir.
Yeah, which loses the hydrogen, that will become the like in this example. Let's see the one which we had taken with. For oxidation, what happened? Hydrogen got removed over here. So which is the oxidizing agent? It's the chlorine. So hydrogen got removed because of chlorine. No? Chlorine took this hydrogen from here. this chlorine becomes the oxidizing agent. Okay, not the guy which loses the because this is this is the substance which got oxidized, H2S, right? The one which loses the oxygen becomes oxidized. Why did it get oxidized? Because of chlorine. Chlorine came and took the hydrogen from here. So chlorine becomes the oxidizing agent. Is that the question you were asking, Pragati? Is it clear?
Yes, sir.
All right. So substance which removes hydrogen, like chlorine over there. Chlorine removed the hydrogen. So which removes hydrogen. Any one of this happens, that will be called your oxidizing agent. Same way, can anyone tell me what should I write for reducing agent?
A substance which gives a hydrogen for reduction, and the second point will be substance which removes the oxygen.
Yes, very good. Since addition of hydrogen becomes reduction, so the substance which gives hydrogen for reduction, that will be your reducing agent. Or if it is related to oxygen, the substance which removes the oxygen. Try to understand this point, which removes. Doesn't mean the substance from where the oxygen was removed, not that one. Which facilitated the movement of oxygen from there. Like in this case, oxygen was removed, right? Why did it get removed? Because of hydrochloric acid. So HCl becomes the reducing agent. Okay. Substance which removes the oxygen.
Sir, can you explain with one more example, sir?
For oxidation reduction.
Yes, sir.
Okay, we'll take more examples, don't worry. This will be your definition or something which you need to remember for oxidizing and reducing agent. And like I said, other than the classical definition, there is one more definition for oxidation and reduction. Okay. So that definition we are going to learn today. Just confirm all of you. Are you people clear with this so far? All the definitions, is it totally, you understand this, right?
Yes, sir.
Yes, sir.
Okay. So whenever hydrogen or oxygen is there in the reaction, you will try to use this logic. Only if hydrogen or oxygen is not there in the reaction, then you will try to think of the new definition which I'm talking about. Okay. Okay. So by this definition, first of all, do you people remember what is metal and non-metal? from the first few classes, I had given you some idea from the periodic table. No, metals will be on the left side of the periodic table. Non-metals will be on the right side. But what is the difference basically between them is metals try to give away electrons. Okay, they give away electrons. So if something gives away electrons, they are normally positively charged. Okay, they are positively charged. Something that gives away electrons means there will be extra positive charge. That's why they become positively charged. And non-metals will be just the opposite. They accept or take electrons. If they take electron from other people, electron is negatively charged, right? So that means they will become negative charge. Okay. Like, for example, if I take NaCl, very common example, you have seen this so many times. What did I tell you? Sodium gives away the electrons and chlorine accepts it. That's why Na is positive, chlorine is negative. This guy is your metal, Na, and chlorine is your non-metal. Okay. So just to fresh up your memories, let's quickly go to the periodic table very, very fast. So all these green things, whatever you see here, they are all metals. All these yellow things, they are non-metals. As you can see, chlorine, fluorine, bromine, all these things are your non-metals. And metals will be most common metals which you see will be here. All of them are metals, of course, but the ones which you'll be seeing so often will be these examples: sodium, magnesium, potassium, calcium, and of course these examples also. These are the ones which you'll be seeing so often: manganese, iron, copper, nickel, cobalt, copper, and zinc. This is cobalt, this is copper. Okay. Yeah, so let's get to the definition. Now that you have some idea about what metals are, what non-metals are, so the new definition of oxidation and reduction will make some sense to you, okay? Remember, this is alternate means definition. But in your board exam, if they ask you to define this thing, you will use the definition which I gave first, okay? This is the definition which you will be using, earlier definition which I gave you. That's for your exams. And, yeah. Okay. So addition of non-metallic elements or removal of metallic elements will be defined as oxidation, and reduction will be just the opposite.
So,
Yes,
so this one is quite confusing.
don't worry, I have not explained it with examples. That's why you are not able to understand. Just try to understand that. Don't try to remember everything now itself. Okay, see, this is, I'm just explaining you right now. I'll take some examples, it'll start making some sense, but in home you'll have to go through this definition again and again, go through the examples again and again, and then it'll start making sense. I know this oxidation reduction can be a little bit confusing because there are so many things to remember, because it can depend on oxygen getting removed or added, hydrogen getting removed or added. So you have to spend some time with it. Don't worry about it, okay? But you have to spend some time with it, and this will become very easy for you then. Trust me. This is not that complicated as it seems to you right now, okay? Just try to spend some time with it, take all the examples and see what's happening. And then all this will become very easy. The addition of non-metallic elements means non-metallic element means something like chlorine. So if you add chlorine, that will be oxidation. Removal of metallic element like sodium. If you remove a metal, that also becomes oxidation. Okay, so we'll take examples. Okay, so I will start with some example which does not have hydrogen or okay. Let's see if I have an example which does not have a hydrogen or oxygen at all. No, at least one of them is always there. Okay. Let's take the same example which we've seen before, but now we will see the same example with respect to oxidation reduction. Anyone understands what do you think the product will be? We have seen this reaction, right? Take copper and heat it with oxygen. What do you get? Have you people seen this reaction before? It's copper oxide, okay? Now, try to explain me, anyone? Where is oxidation happening? Where is the reduction happening in this reaction? Can anyone tell me? Where is the oxidation happening? Forget about the new definition. Just use your own logic, whatever we have not studied so far.
Copper is getting oxidized, sir.
Say that again.
Copper is getting oxidized.
Yes, very good. Copper is getting oxidized to copper oxide. Excellent. Why is it happening? What is the reason for that?
Because oxygen is added.
Yes, very good. Oxygen is addition of oxygen. That's how we normally write it. So we know addition of oxygen marks the oxidation reduction reaction. Okay, and I've always told you that if oxidation happens, reduction also has to happen. Where is the reduction happening? If copper is getting oxidized, who is getting reduced?
Oxygen.
It has to be. This is the only other reactant, no? Like I said, answer to all those 4 questions, it will always be in the reactant. So if this is the guy who's getting oxidized, the other one has to get reduced. And since there is only one product, so oxygen is getting reduced to copper oxide again. But here, the old definition, can it help you to understand how reduction is happening here? The old definition, is it helping?
No, sir.
No, sir.
Yes, the old definition fails to explain how reduction is happening over here. Because oxygen, there was a metal added over here, copper. So how this, there is no hydrogen involved, oxygen, it is already there, something got added to oxygen. So how should I define it? That is where this new definition comes to picture. Okay, remember we are expecting this to be reduction reaction, right? So let's read the definition for reduction first. Addition of metallic element. You see this copper is metal, right? Earlier it was only oxygen, copper got added. That's why this is reduction, because of this point. Addition of metallic element makes it reduction reaction. So the reason will be addition of metal or metallic element. Addition of metal makes it reduction. So is it starting to make a little bit of sense at least? No? Okay. Let's take more example. So here again, the answer, let's answer the questions. Okay, tell me the answer to these 4 questions, guys. Very, very fast. You should be able to answer it now.
Substance oxidized is copper, sir.
Yes, very good. Copper.
Substance reduced is oxygen, and oxidizing agent is oxygen. Reducing agent is copper.
Okay. Everyone is okay with this answer? Can everyone get to this answer? All of you? Confirm quickly.
Yes, sir.
Okay.
Yes, sir.
Let's go to the second example. all these are not just second, first example. They are continuing from the previous one. So let me not use that name so that you get confused. Let me use the same example numbers. So this was fourth example. All these are examples of oxidation reduction. So anyone you can use, okay? So this is not the first one, but fifth one. This would be your sixth example of oxidation reduction. Peroxide reacting with hydrogen to give you copper and water. Tell me quickly, guys, what's happening here?
Hydrogen is getting oxidized, sir.
Okay. So hydrogen is getting oxidized. What is the reason behind that?
Addition of a non-metal or oxygen.
But here it's very straightforward. Oxygen is getting added, so we can use the straightforward definition. Okay. Yeah, this one has hydrogen and oxygen, so here it is simple addition of oxygen. So this is oxidation, and here this is reduction.
Copper.
Yes. So copper oxide is getting reduced to copper. So this is also old definition only. So here also just removal of oxygen. Okay. Could you tell me the answer for these questions very, very fast?
Substance getting oxidized is hydrogen, sir. Substance getting reduced is copper oxide. Oxidizing agent is copper oxide, and reducing agent is hydrogen.
So most of your school exam questions will be based on these things, hydrogen and oxygen based questions, but you need to be aware of some examples where, like we saw in the previous example, the fifth example, we were not able to explain the reduction using the old definition. So we have to use the new definition to explain that. Addition of metal cause the reduction. Okay. Not seeing many examples which totally need to remove the hydrogen or oxygen from the equation. Let me give you one more example. This one, which should be at least a little bit relevant to the new definition. So, seventh example, right? So here, where is the oxidation happening? You can see very clearly sodium is getting oxidized to Na2O. So this is very simple addition of oxygen. There should be no doubt. Okay, reduction, same logic like the previous one. Oxygen is getting reduced to Na2O. How do you explain it this time? Anyone?
Addition of a metal, sir. So reduction.
Yes, addition of the metal. What is that metal? Sodium. That's why this is reduction again. Okay, all the other examples which I see, they are, yeah, even one more. So do I need to write those things over here? Or will you people be able to write it? Try to write this on your own, okay? Later, when you note down this thing in home. Fill that up. Let's take, what was that? Which example was that? 7. Tell me, who's getting oxidized, who's getting reduced? What?
Carbon is getting oxidized, sir.
Yes, carbon is getting oxidized to.
Carbon dioxide.
Yes, I need answer from everyone, guys. Do you understand this? Carbon, it was only carbon here. You see this side, oxygen got added to the carbon, no? That is how you identify oxidation is happening. Oxygen got added, addition of oxygen. We have been doing this so many times, right? Okay, same way, lead oxide is getting reduced to lead. What is the reason here? Removal of oxygen. Okay. See, addition of oxygen means what? Oxygen is metal or non-metal?
Non-metal.
Metal.
Yes. So remember, whenever we say addition of oxygen, oxygen is a non-metal actually. That is why we say that oxidation is happening. All right. So I think we have had enough examples of this. Yeah. So we will write down the answer for those 4 questions here also. For the sake of doing, you will do this 9th one example. So put down all the markings, like where oxidation is happening, where reduction is happening, what is the reason for that. So you will fill up all that, okay, for this one also. So this is your assignment. This one is also your assignment. Fill up the substances here also. Okay. Right. So anyone has any doubt in oxidation reduction or any of the previous reactions we have seen so far, the different types?
No, sir.
So tell me then, what are the different types of reactions we have studied so far?
Combination reaction,
Displacement reaction, double displacement reaction.
decomposition reaction,
Yeah, always try to remember in sequence, because when you do that, no, when you remember things in sequence, it will help you to bring out the examples. It's a better way to organize things in your mind. Okay. So first we studied combination, then the opposite of combination was?
decomposition reaction.
Yes. Decomposition. Other people can also answer, everyone. What was the next one? What did we study after that?
Displacement reaction,
Yes. Displacement.
double
Then
displacement. Oxidizing reduction reaction.
and then we studied,
Redox.
yes, oxidation reduction, which is also called redox. And remember, double displacement reactions, we studied precipitation reactions also along with that. Most of the double displacement reactions were precipitation reactions also. Okay. And in this decomposition, we studied some types of decomposition. What were the types? Anyone remembers?
Electrolytic
Thermal,
reaction,
electrolytic, photolytic.
photolytic,
What was the first one? Remember the sequence.
electrolytic,
Thermal.
Thermal,
Then
electrolytic,
electrolytic, photolytic.
okay. See, I'm asking you to remember this thing in sequence. Don't take it like I'm asking you to mug up in the same order, however I taught you. It's not like that, okay? Like I told you, remembering things in a sequence in which you learned, it's always a better way to organize information in your mind. You will be able to bring it out better. You will be able to remember this thing for a longer time if you organize it in proper order, okay? That's why I try to always give attention to the order also, okay? It's important. Fine, so we have actually completed all the types of chemical reactions. And in going through all this, actually, you would have seen that we have gone through so many examples. And you might be actually intimidated by that also, how to remember all those. And just for one chapter, these many reactions are there. What will happen when I read more chapters? So let me tell you that whatever reactions we have seen here so far, don't think that they're only for chapter 1. All these will come again and again. And these reactions, whatever you're learning now, they will help you in your second chapter, third chapter. They will help you a lot if you understand whatever we have done in this one. Okay. So they're not just for one chapter. Okay, that's good. So in this chapter right now, only topic which is remaining now. Anyone knows what topic is remaining? You should always keep track of what we have studied, what is remaining. Okay. So only topic that's remaining in your this now is corrosion and rancidity.
इसको छोड़ो, गार्डन वाला रीड करो, लगभग गार्डन वाला निकाल के देखो। गार्डन वाला बैठ करो।
Yes, this is the only topic which is remaining. We will take it up tomorrow. Okay, we'll see this tomorrow. Try to read this on your own also, and we'll take it up tomorrow. And after that, we'll start going through the questions. CRT questions also, will cover all of them one by one, and then additional questions also. Anyone has anything for me? Any questions, guys? Any doubts? Anything? No? Okay. Then that's it for today. I'll see you guys tomorrow. Okay. Bye. See you all.